So APIs. Okay, so what happened? We had a variety of people screen scraping, and we had a lot of problems, the legal problems, the logistical problems, and meanwhile, of course, sites were becoming increasingly restricted with their data because there was a real value attached to the data. Fortunately, this coincided with a moment when we saw increased need for transferring data across platforms for the survival of the platform. So at the same time that Facebook or Google or other large players in the game did not want to have allow someone else to scrape all their data, they had a real need to find a way to share their data, integrate it with other platforms. So you could, for example, build an app that would allow you to share data from the New York Times on Facebook or Spotify on Facebook or something like that, right? And so APIs have been around for a long time now. It's essentially just an online pipeline for information that connects multiple sites. What's distinctive about it is that, or what's distinctive about them, is that they typically allow certain types of people to request certain types of information from certain websites. So they have a mechanism known as credentialing or giving each person a certain type of code that gives you certain permissions to access certain types of data from a data set. So let's look at some of the examples. First of all, we're seeing APIs just explode. There's an API for, you name a big site, it probably has an API now. This is some historical data. This only takes us up to 2011. That's kind of embarrassing. We went to 2017, right? Again, I think like our big data example last time, it might be the size of the building. We're keeping track of APIs of interest to social scientists here. This is, that's going to come later. Sorry, that's the end of the talk. But you can, if you want to fast forward, you can go there. First, though, I'd like us to just look at a worked example of an API. If you visit this link, you'll be redirected to a sandbox or a kind of like a play place where we can play with some code and see how an API works. This is the Facebook Graph API. And this tool is called the Facebook Graph API Explorer. So the way this thing works, up here, we have something called an access token, which is our permission, our code that allows us to access certain types of information. Here we put in certain requests for information, and here we see the output of what the API gives us. So for example, it's going to default to showing your name, I believe. If you're logged into Facebook, if you're not logged into Facebook, you won't get an access token. Think of it this way: Facebook, in this case, needs a way of keeping track of all of us, not only so it knows what information we are supposed to have access to, but also how often we're requesting the access. That's one reason why we have to be logged in. As soon as we do that, we're giving Facebook a way of tracking us, essentially. And here you'll see over here, you can search for different fields and put them in, and you'll see whether or not you have access to the data here. So for example, if you write me/friends, you should see a list of your friends. What we're actually doing behind the scenes in the sandbox is just preparing this for us. We're creating different URLs that have a really long, messy list of data we're requesting. It might look like graph.facebook.com /username /friends / this long access code at the end. And then if you put that in your browser, you'd see what we're seeing output here in your browser. And so big picture, what we're doing is repeatedly constructing different types of URLs and scraping what's often JSON, a data format, or XML, different type of data format, from that web page. That's a big picture. That's a way of thinking about how an API is working. The really nice thing, though, is that this allows us to get data under the terms of service. So we need to be sensitive to what types of data we're allowed to ask for, how often we're allowed to ask for it, and I'll show you some ways of learning about how often, what your level of access is. But big picture, this is what an API is. This is what an API gives us. It also allows us to, usually each API will have a long list of documentation which will tell you what type of fields or variables are available from the API and what type of permission is required to access which type of data. So if you type in someone's name here who you are not friends with, using their Facebook login ID, and that would be what appears at the top of the URL when you Google that person on Facebook, you'll see whether or not you can get their data. If you can't get their data, you'll see something like OAuth exception, and that's telling you you don't have permission to access that data. So if you play around with this for a while, you'll see, there's a lot of potentially interesting data on here. So if you click here, you'll see, you can get birthday and gender and musical tastes and all that kind of stuff, but only for people for whom you have that access. So only typically your friends. So this kind of default Facebook analysis would be a not so interesting analysis of your friends and their musical taste, right? Unless you can get authentication to access other people's Facebook data, and that's where apps is going to come in, and that's where I think there's some progress to be made. But just big picture, this is how an API works. This is the type of data process. We create a URL that includes our credentials, our access token in the case of Facebook. And by the way, all APIs have entirely different kinds of jargon, and one of the real pains of working with APIs is learning the language that each API uses to describe different pieces of information that you might want, and that can vary tremendously across platforms. So on Facebook, you're going to need an access token. On Twitter, you're going to need an access secret and an access token. There's just a lot of verbiage that, particularly for people who aren't very fluent in coding, will be a little bit frustrating at first. Fortunately, there are many, many packages that allow you to work with APIs without painstakingly figuring out exactly what type of language you need to access which part of the data. We're going to work through an example with the Twitter package. So once again, and of course there's many packages for accessing Twitter in Python as well. And this package is going to allow us to do things like get someone's list of followers, get their tweets, build network data, and so on and so forth. But first, we need credentials. So on the sandbox, Facebook automatically generated a temporary access token that we could use to access data. The preferable way is to get your credentials by registering as a developer or a software developer with the site that you want to access. So in the case of Twitter, you have to go here, apps.twitter.com. This takes you to this page, and if you're logged in, then you have to effectively create a new app. And one of the weird things here, especially for people who aren't used to coding in the CS world, app has a very expansive meaning. Here, we're not building something that's going to help someone recommend a Spotify song they like. We're simply getting credentials that allow us to access information. So this is a bit of a weird step. But officially, this is how we're announcing ourselves to, in this case, Twitter, as someone who wants to access data. And so we have to go through some steps to ensure that we're not someone creating a malicious attack on the website, and that, name ourselves. Twitter now requires two-factor authentication to register as a developer, meaning you have to give your phone number and get a text message in order to register as a developer, actually to sign up for Twitter now. So that's a mechanism that they're using to keep track of us and make sure we are not, for example, producing lots of bots that are doing bad things or scraping too much information in too short amount of time, or trying to somehow systematically take down one of Twitter's servers. On the same page, you'll get your credentials here. Twitter, for whatever reason, requires more credentials than Facebook. Yeah, Kevin.
So I had a question about the phone numbers. So I have a bunch of fake accounts, and I've been getting blocked because I think that they're onto me. Does anyone have any suggestions for like a site to get phone numbers that you could register with, and they would just lay off of you?
Google Voice.
Google Voice.
I think it puts you on some, again, shaky ground. I would think hard about, is it is the goal to get a lot of data quickly, or is it what's the problem that you're trying to solve with the multiple accounts?
I'm trying to do multiple projects at the same time.
I see. And so you're getting, Twitter's rate limiting you, meaning they're telling you can't get all the data you want to get in the amount of time you want to get.
Exactly, yeah.
I think it's probably a violation of the terms of service. I probably would think about whether you could stagger your data collection personally, just so you don't get in that situation where you're blocked as a developer of Twitter, or even worse, that they tell you can't use the data you've collected. But I mean, I guess it's a I think we should have asked the speaker last night how they collected their data. That's a lot of data. I don't know the answer. But
I think that he said that he used only 10 keys or something like that. So also check that you are collecting the data smartly and not too dumbly.
yeah, there's also ways. We'll see if you can request a lot of information in one call or a smaller amount repeatedly, and sometimes there's ways of batching your requests into a single request rather than making multiple calls again and again and again, and that might also help you get around the problem. So we get these things, these credentials in Twitter. They're called keys and tokens. There are 4 of them. This is from a page, an app that I built for this class, and the my credentials are blocked out here. Yours would appear there. And then I mentioned earlier that the nice thing about packages designed to work with APIs is they prepare a list of scripts for you that help you do things. Like in this case, announce yourself as a registered user of Twitter. And this allows you to then make requests for data from Twitter's API. This function here, set up Twitter OAuth, is doing that for you using those 4 codes that you got when you registered as a developer. One of the other challenges of working with an API is just figuring out how to get credentials and how to register them. Sometimes it's as simple as getting one code and appending it to a URL. Other times there's these more involved processes. It probably depends on the size of the site and the amount of resources and the sophistication of its API. Once we're authenticated, we have a number of functions prepared within that Twitter package that allow us to get data. This get user function allows us to define a user we're interested in tracking, whoever this guy is. User timeline gets those tweets. These are being pulled now from recent live streaming challenges on Twitter. You'll see we created an object called tweets. We can get a list of followers, people I just followed, and people who follow me, and so on and so forth. And we can use all this data, pipe it back. Here's favorites, tweets I liked, and here's a way of moving this messy list data into a neat data frame, which is an object with consistent rows and columns in R. Anja and then Ethan. Yeah.
Again, I've also not done any of this before, so maybe a naive question, but if you register as a developer and you start scraping information about a set of people that you have login information from a different source, would these people be notified that you are collecting their information, or would all of this be done in the background?
So in the case of Twitter, because this is all default public, unless if the user has registered their account as private, so if you maybe seen on Twitter, you can say this person's tweets are private. Mm-hmm. We couldn't do this.
Okay.
So again, it's a platform specific thing. If we tried to get data in this manner from Facebook, we would for someone for whom we don't have authentication to access their data. I don't know of a way at present where the user wouldn't be asked for that data, usually in the form of an authentication dialog where something says this app is trying to access this type of data, blah, 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 and maybe linking to their terms of service. But in the case of Twitter, in this exercise, nobody's getting any kind of update that I'm scraping their data, no. Yeah.
We're often worried that, for example, if we were to ask people for their Twitter handles, and we would then kind of try to get information from their Twitter profiles, that they might be identified as study members, and already being identified as a study member is problematic for some of the big surveys that are conducted here in the US.
Sure. Yeah.
Okay. Thank you.
Yeah. I think Matt's going to talk a little about linking surveys and big data. Are you going to cover that, or?
We'll talk about it a little bit, but it does also bring up some of the issues from yesterday about contextual integrity. That is, you could say that the data on Twitter is public, and it is in some sense public, but then when you take that data and move it into a different set, when it flows in ways that people aren't expecting, this can lead to some
Oh, but
complexity.
if you do ask for permission in the survey and ask for their Twitter handle or
Okay, so it's important to understand this concept of rate limiting. This is what happens when you ask for too much data within too short a period of time. So if, for example, we all of a sudden asked Twitter we made 1,000 API requests within 5 seconds or something like that, we would pretty quickly get rate limited, meaning we get a message that says, depending on how the API works, hopefully we get a message that explains it might just say something again like OAuth error or SSL error. These are various messages that are referring to problems in authenticating. Typically what will happen is you get timed out, meaning you can't access the data for some regular interval like 15 minutes or something like that. And so if you try, and you have to wait 15 minutes before you can get data again. So the key thing here is to understand that you need to know what the rate limits are. Sites vary as to how public they make the rate limiting information. I think sites vary because they are worried that a coder could, if they knew the rate limits, they can push it all the way up to limit in various coordinated ways and create problems. Fortunately, those sites like Twitter will tell you what your current rate limits are. So you can make an API call that asks what your current, how much data you're allowed to get within what time interval. And if you run this line of code in the Twitter package, you're making an API call that tells you that information. So you might see you're allowed to scrape 1,000 accounts in every 5 minutes or something like that. This type of information can then be used to put pauses in your code. In R, you might use a function like sys.sleep to say pause for 30 seconds and then repeat the data collection process. But it's important to understand that you need to have you need to appreciate why you're getting rate. So some of the examples people have brought up, they want a lot of information, they can't get it. Figure out what these rate limits are. So if we look at this data, we would see now that we've moved it to a data frame in this step, we now have effectively an edge list or network data that links each person. Here's an example of how we might take the data we scraped from that earlier web page and put it into a loop where we're asking for each person's Twitter followers so that we could construct a social network of all the users in the list of top 100 followers. Why would we want to do that? I don't know. I mean, there's probably not many interesting research questions about the top 100 celebrities on Twitter, but you could obviously repurpose this to get any list of Twitter users. There's probably more elegant ways to code this, but this is just one example of how you might combine API calls within a loop to populate a data frame to create, in this case, a network data set that we could equally create a list of users' tweets and network data. This would take a long time in part because of rate limiting if you're trying to run this right now. There is actually, you know what, I don't have this data set on the GitHub. I'll put that up during the break. This is what the data would look like after we've made all those calls. If you want to load this data, you need to put this data set in your working directory for this line of code to work. Questions about how to use an R package to get data from an API, or any kind of package or module in Python to get data from an API, or about rate limiting, or about credentialing, or about ethics in IRB restrictions. No. Okay. Let me just say then that there's many packages for many other APIs. This is a real resource because someone else has done the yeoman's work of figuring out how to make the API call, which again requires creating a rather long URL that combines your credentials and the type of data you're requesting. There's just a ton of different packages on both Python and R that will let you get all sorts of interesting data. and there's many more that are not on the central archive network that are on the that are on GitHub, which is a great resource to find packages for working with APIs. Just brief. Oh, sorry. Yeah.
Yeah, can you have also access to data from Viber or WhatsApp as from Twitter?
WhatsApp. Does anybody know? I'm not aware of whether WhatsApp or
You can download
Weibo
it.
has a package, right? Yeah, Weibo has a package, but I don't know that WhatsApp does. Does anybody know? I think a lot of that data is private, so it'd probably be hard to get.
Be
But
kind of ahead of
Weibo, there's plenty of there's a lot of papers that use Weibo data. So I would, yeah, I haven't worked with it myself, but it sounds like maybe Yo-Yo, have you worked with it, or do you?
On WhatsApp, some of my colleagues are just running it on the mobile phone and taking screenshots automatically on their
Oh wow.
mobile device. I can ask if they can share something of that.
Yeah, sure. Yeah, please. Yeah, that'd be great. Yeah. I also just want to point out that APIs are no longer principally for data collection. APIs also do a variety of analysis. So Abdullah gave us the example earlier of an API where you could send a Twitter account handle, and that API will then run some code somewhere else to determine whether that account is a bot. There's a variety of APIs that do voice recognition, OCR, optical character recognition for transcribing text, facial detection and images, visualization. I mean, this is where APIs are really becoming a tool that's indispensable, and you know, I'm probably missing some important examples. Anybody have other examples of useful APIs, particularly ones that are useful for some social science purpose?
So I've used the U.S. Census actually has a pretty robust set of APIs, both for getting data and for things like geocoding. Like you want to know what census tract an address or lat long is in.
Sure.
Yeah.
Great.
The documentation is kind of hard to navigate, but the APIs themselves are pretty good.
As a reminder to me, Gary King is also the pioneer of the Dataverse, which is which has an API, which is a archive of data sets of interest to social scientists that has an API that allows you to pull data in a similar way, and that saves you. It can save you time with, for example, data cleaning or something like that. Yeah.
I use Ace++. I think a few other people use it for like estimating the demographic characteristics of the picture. So
Oh,
you
cool.
just like send a URL picture to the and it'll give you the race, gender,
Wow.
things like the smile, different
What's
stuff
that
like
again?
that.
Great. Will you share that on Slack, please?
Yeah.
Thank you. I also have a list here. This is the one I mentioned earlier. I'm just going to skip ahead because we're probably done with these guys. But where is it? Here. This last slide and on this section of the slides is a crowdsourced list of APIs that I curate. I hope we add a few lines today because I think it only has like 30 lines or so. It's mostly Facebook, Twitter, Google, New York Times. But there's probably many more that I haven't looked at this list in a year or two, so I'd love for people to add to it. Yeah, Matt.
So would you want to hear more about data analysis APIs also beyond data collection? Because now it seems to be focused more on data collection.
This one, yeah, I think this one's probably more useful. Well, it says of interest to social scientists, so yeah, why not? Yeah. Maybe we should start a new tab for data analysis, though, or something like that, versus data collection. Okay, so again, we're rushing through all the code for working with an API. There's worked examples with Twitter and Facebook on the code linked on the schedule. I also have a variety of resources on my website that take you through much more extended examples of different use cases and a variety of different APIs. Let me though, before we take a break, let me say, let me just go over two things. Often there's no package. So let's say you're the first, you want some data from an API and nobody has made a convenient package with nice functions that do all this work for you. Then you have to write code that essentially constructs different URLs and then scrapes the resultant data, often in JSON format or XML format, from a HTML document, or sorry, from a JSON document. So in this case, let's pretend there was no package for Google Maps. There is. In fact, there's several now. There's packages for Google Trends and packages for what else? Google Finance. There's all, Google has hundreds of APIs. And in this case, let's say we wanted to put in different locations and get their latitude and longitude to do something like reverse engineering the home value like Michael Macy did last night. We might realize that the data we want to iterate through is, in this case, Durham, North Carolina, proud location of Duke University, where we want to then put in a list of different, say, college names or something, or city names. We need to write a function. Here's an example of a function that would take in an input, call it an address, and then put it in between the two parts of the URL, the prefix and the suffix, if you will, everything in between the equal signs here, or equal sign and the and sign, which through a little experimentation you could learn is what produces the data you might like. And then you can pass different locations into this function. And if you need a refresher on functions, that the data camp has a good exercise on that. They can, of course, become pretty complex. Here we're returning a URL. And then if we go to that URL, if we pasted that in our web browser, which is useful to do every once in a while just to verify that you think you're getting the information that you're getting, we would see this JSON data. And this is a data format that we can then read into Python or R or whatever. And using something like this, this is an example of how you would extract the latitude and longitude that was in, if you couldn't see it in this, but it's one of the pieces of information here is the latitude and longitude of Durham, North Carolina, or whatever we're parsing through or passing through that function. And here's how we store those things. Once again, we can loop, we can iterate. Obviously, that's the whole point here. Let me finally say, especially for people new to working with, especially social media data, and this is kind of like, maybe we can talk about this more over a break or lunch if you don't have, or with one of the TAs. It's important that you just know that time and date data have some unique properties that can make it difficult to work with, essentially because of time zones and differences in the way that people describe time. There's a variety of useful packages. Like often you'll want to bin all the tweets from one day or 1 hour into one bin and then visualize it or something like that. To do that, you have to learn how to take what is often a long, messy text string and create what's often referred to as a date object. And there's a variety of different types of objects that can store date data. And there's a variety of functions. In R here, we're using the strip time function. There's other functions that also help you work with date data. Just kind of a big a warning that you'll need to acquire some new skills if you want to work with over time data. Most of us do. You'll want to become familiar with Unix time, which is a number of seconds that have elapsed since 1970, January 1st, and that's a more universal way of standardizing time across time zones. This is just a little tip.